start, you can't stop. Okay. Well.
Good day, everyone. I'm Gerald Lindo with the Caribbean Center for Renewable Energy and Energy Efficiency, and you have joined us for our training session on wind resource assessments. We're slated to begin in about 3.5 minutes, so please sit tight. We'll begin promptly at 10 o'clock. Thank you. Just so you know, on all of your screens, you should have an option for the Q&A, show Q&A. Because of the volume of anticipated attendees, we won't have any audio from the audience today, but please feel free to share your comments and questions through the Q&A chat box. We have 11 attendees so far. Thank you for those who came early. We are going to be starting promptly within the next 2 minutes. So if you want to grab a coffee, do so now. As long as the coffee is right beside you. I presume everybody's at home and therefore close to the kitchens. All right, it is 10 a.m. Atlantic Standard Time by my clock, and we are slated to begin. We have 19 attendees in the conference room so far, and I anticipate more will come. So thank you for coming, and let's get this underway. My name is Gerald Lindo, and I'm from the Caribbean Center for Renewable Energy and Energy Efficiency. We are an entity of CARICOM, and we have a mandate to promote renewable energy and energy efficiency throughout the region in furtherance of the region's energy transition. That mandate led us to this series that you're tuned into today. Some months ago, at the 82nd special meeting of the Council of Trade and Economic Development for CARICOM, CARICOM endorses the methodology, principles, and practices of integrated resource planning as the preferred mechanism for energy sector planning in member states. Now, what is integrated resource planning? Integrated resource planning is an approach to energy sector planning that is similar to traditional integrated resource planning methods that we have seen in the energy sector, but introduce extra elements of resilience, which is so critical for our region at this time. The IRP methodology requires an appreciation of a lot of the technical issues arising from grid expansion and renewable energy integration. And as such, the CCREEE works with stakeholders towards delivering its IRPs and building capacity throughout the region for the performance of IRPs. And this session that you're participating in today is within that series. We're trying to build institutional capacity, in this case, around wind energy. Wind energy is one of the more technologically mature forms of renewable energy that the Caribbean stakeholders are seeing and using, and they're seeking to deploy it in the region as the region transitions towards renewable energy. However, wind energy is tricky. The resource is almost entirely dependent on location, and the output of a wind farm is highly sensitive to wind speed. So the nature of the resource and understanding the resource is absolutely critical for the deployment of wind energy in the region. Project developers and energy planners need to very carefully consider technology and siting, and they have to conduct very careful wind resource assessments before building wind generation capacity and putting down assets, otherwise they're going to lose their investment. So the question arises, how are wind energy resources assessed? What critical factors should project developers and planners consider when planning wind energy installations, and what effects may climate change have on wind project development as well? That's why we're here today, to talk about wind resource assessment within the context of the IRP. Today, we are going to hear from our expert, who is brought to you in partnership with some of the sponsors you see on screen. So I want to say big up and thank you very much to the European Union, specifically the Deutsche Gesellschaft für internationale Zusammenarbeit, GRZ, that is the German aid arm that's very active in the region, who has helped to bring this session together, as well as other sponsors such as the Kingdom of Spain and the Austrian Development Agency. Let's get to the session. And I wanted to pay very special attention to our presenter today, because by all accounts, by all reasonable expectations, this man is a true expert. His name is Mr. Sanjay Simmons. Now, Sanjay has a BSc in Alternative Energy, Mathematics, and Computer Science, and he has an MPhil in Physics, all from UWI Mona. Sanjay has over a decade of professional experience in wind. He's conducted a number of resource assessments, including an IDB-sponsored island-wide wind resource assessment for Jamaica in 2011. He works at the Wigton Wind Farm Jamaica Limited. You see the logo up there, where he's both training coordinator and engineer responsible for maintenance of the wind turbine. So by all accounts, an expert, and we're very glad to have him here today. So please give your attention to Sanjay. Once again, as we go, if you have any questions, post them in the chat box so we can get to them in an orderly fashion. Thank you very much, and look forward to working with you all today.
So, morning everyone. So I'm actually pleased to be here to deliver this training manual that was coordinated between us and CCREEE. Today should be, even though it's online, I will try to make it as easy as possible for you to grasp the information so that there is a level of understanding that can take place. So we will just jump right into it, and thanks again to Jerry for that brief introduction. As I said before, I am one of the experts here at the Wigton Wind Farm within the field of wind energy. So today, I hope, should be a good one for everyone. So before I actually start the presentation, one of the things that I want to do is actually introduce Wigton Wind Farm. For those who don't know, we are the largest wind farm in the English-speaking Caribbean, And I have a very small 5-minute quick video that will give a quick synopsis of what is it that takes place here on a day-to-day basis.
Before the groundbreaking of Wigton 3 in February 2015, the Petroleum Corporation of Jamaica and its subsidiary Wigton Wind Farm Limited spent 15 years laying the foundation through legislature, partnerships, awards, and the construction of Wigton 1 and 2. For this 24-megawatt expansion of the wind farm complex in Rose Hill, Wigton signed a contract with the Spanish firm Gamesa. Gamesa, a global technology leader in wind energy, executed a turnkey construction project that added 12 G80 2.0 megawatt wind turbines to lands in Rose Hill, Manchester, leased from the bauxite company Alpart. This contract allowed for the creation of 147 construction jobs for Jamaicans and 3 permanent engineer posts. These turbines have a hub height of 67 meters and 80-meter rotor diameter, and the new plant generates approximately 63.1 gigawatt hours and can provide electrical energy for approximately 31,000 homes. Wigton 3 expansion lessens the amount of oil imported by 37,000 barrels per year, which saves Jamaica $1.9 million per year. In addition, Wigton 3 reduces Jamaica's annual carbon dioxide emissions by 45,000 tons. The 44 wind turbines at the Wigton wind farm have a capacity of 62.7 megawatts. They can provide electricity for over 82,000 homes across Jamaica, reduce annual carbon dioxide emissions by 119,000 tons, and lessen the number of barrels of oil imported by 96,000, which translates to $4.9 million saved. Wigton is now the largest wind energy facility in Jamaica and the English-speaking Caribbean, and with its commitment to meeting the government's targets, it will no doubt continue to be a trailblazer in the energy sector. But how are hectares of land transformed to host a profitable and sustainable wind energy plant? Before the rotor is mounted, the wind turbine tower erected, cement poured, steel placed, and trenches dug, the land has to be evaluated for its ability to support the massive wind turbines. Under the turnkey agreement with Gamesa, the contractors assessed the site for suitable locations for each turbine. This included engineering development, topographical and geotechnical surveys, and detailed foundation design. In addition, wind studies of the proposed area and applications for and procuring of environmental and building permits were done long before a wind turbine was erected. Once the project is properly documented, poles 17.2 meters wide and 3.9 meters deep are dug and then filled with tons of concrete. This process takes place over several weeks and uses 42 trucks of specially formulated concrete for each wind turbine foundation. In addition to the excavation for the base of the wind turbines, excavation is done for the substation and trenches that will transport the electrical energy via cables from the wind turbine to the substation and then to the nearby JPS substation. Once the site is prepared, the wind turbine components make their way to the wind farm. The wind turbines are manufactured by Spanish-based company Gamesa. They're shipped to Jamaica in pieces and assembled on site. But transporting 12 wind turbines that each stand at 67 meters with blades weighing 6,500 kilograms and a nacelle that weighs 71,000 kilograms is no easy feat. Cranes are used to move the turbine parts from the ship to a trailer, which then transports the turbines to the Rose Hill facility at night. It takes weeks of convoys and traffic control to transport all of the turbine parts to the Rose Hill site. Once on site, it takes 2 days to install a turbine. Once the turbine is assembled, Tested and commissioned, it is ready to generate electricity. Generating electricity from the wind will take Jamaica closer to attaining energy security by reducing the country's dependence on imported oil and assist Jamaica to comply with international conventions on climate change. Wigton leads by example, creating a modern, efficient, sustainable energy generating facility that utilizes renewable energy, provides green jobs, saves Jamaica money, and facilitates Jamaica's energy security. Wigton Wind Farm, working to secure Jamaica's future.
All right, so that was, as I said, a quick introduction to what is it that we do here at the Wigton Wind Farm. So now we're about to jump right into our presentation that we have planned for today. If you have any questions, as what Gerald has said, you just post them in the chat, and at the different intersections or the interjections of the presentation, I will answer as much as possible. All right, so as we're about to begin the presentation, so the length is roughly or approximately 3 hours. And of course, it is the training manual for wind resource assessments, as in what is it that is we undertake, or what is it that we look out for during the entire process of a wind resource assessment from the start to the finish. So just a quick disclaimer that the material that we are presenting today, it is produced by the Renewable Academy out of Germany between the years of 2014 to 2016, and of course it contains properties of others, and it's only for educational purposes within the field of wind energy. Any other uses or purposes is actually prohibited. So for today, we're actually looking to introduce the participants to the wind energy resource. So where does this wind come from? How does it affect the entire region? What is it that we have to do to harvest it, and how is it that we can quantify it? The other deliverable that we look at is how do we assess it? How do we measure it? And what tools are there available that we can use to manipulate this data? So in other words, how is it that we can perform some of the common data assessments? The other thing that we look to achieve in this presentation is how is it that we can now use measured data to generate a wind map, so you can have an idea of where are the stronger wind regimes that exist within your island or whichever country that you are from. How is it that the data that you have, that you're about to measure, data that you quantify, how is it a little bit different when you're assessing it versus when you're looking to implement it? And then some of the steps that you need to create a bankable report, a report that you take to a financial institution for them to provide the funds that you need so that you can invest in your wind farm. And then one of the other outcomes that we're looking at is just to review all the feasibility considerations that are there and some of the climate vulnerability impacts that can exist. So the different steps that are involved in the stages, whether it be after you excavate a land, declare a land, what is it that you have to look out for, what is it that you have to report. So stuff like that, and then the different impacts that you have to analyze. So we're jumping right in, and we're looking to first start wind resource. Where does it come from? So wind is actually a form of solar energy, and it is caused by the heating of the atmosphere, which is not even. In other words, the different layers of the atmosphere that the sun has to pass through, it creates movement. So once you have that movement, and once it is governed by the rotation of the Earth, and of course, Earth's surface is not a full flat surface, there are irregularities right across. So a country like Barbados, where it's not that much hilly terrain, versus a country like Jamaica, a country like Trinidad, different islands, different surfaces, different temperatures of the seas. All of these partake in the movement of this air. And that movement of the air is what you have as wind. So in other words, and the key point here is to always remember is that wind is a form of solar energy. So solar energy is the key energy form in renewable energy on a whole. So whether it be hydro plants or wind energy or geothermal, the core energy form is from the sun. Always remember that. So in looking at this temperature map that we have, the sea surface temperature that we see running here is more or less what takes place right now. It won't be like this. It's an average. So of course, us being the Caribbean region, we exist in a little bit warmer territory. And that warm air brings a different level of interference with the air surrounded by us, whether it be from the atmosphere that exists over the Atlantic Ocean or the Pacific Ocean. All those interferences plays a part in the air that we receive here in the Caribbean region. So some of the factors that actually affect this, and we're going to list them, is the Coriolis force. We have something called the pressure gradient force, and we also have something called a friction force. So all these three factors, they affect wind, whether it be globally, regionally, or locally, meaning within the island you are from, or country that you are from. Now on a global scale, the Coriolis effect is what is known as the deflection of wind due to Earth's rotation. So it's actually an apparent force. It's a force that you cannot see, but it actually does exist. And what it does is air or rotation within the northern hemisphere is deflected in one way, and the rotation in the southern hemisphere is deflected the other way. And it is more detailed in the upcoming slide where you can see in the northern hemisphere, you have the rotation due to the axis, and then because of the northeast trade winds. So if you think about the whole rotation of a hurricane and you see how that rotates, and then if you think about the rotation of a typhoon that affects southern Asia, look at that rotation. That is all due to the Coriolis force, and it impacts wind globally. And remember, it's an apparent force. It's a force that exists. You can't see it, but we know that it exists. It is there. The other factor that does include wind globally is the pressure gradient force. Now, this is just a pressure difference between two locations. So the northeast trades, the southeast trades, all converge at a certain intersection, and that section is called the intertropical convergence zone. In that zone, that is where we have a lot of turbulence taking place. Now, it so happens that that zone actually interferes with us as a Caribbean region, because that is where they meet during the equatorial regions. So if you think about it, during the quote-unquote the winter months for us here in the Caribbean, so I'm not talking the actual winter that exists in the States, but more the winter that exists during a time period. So in the months of January, December, that section, the ITZZ, it actually is a little bit more to the south. So what you find is that the wind actually exists a little bit more strongly from the northeast. Now, while time progresses and we approach up to the months of June, July, that zone actually moves forward, it moves north. And then that actual disturbance that is taking place, if you're able to think about the hurricane season, when it actually does begin, it starts at June 1st. That is only because of the ITZZ, that shift. That shift is bringing a huge turbulence, and then if you notice as well, the winds are more directly from the east. So hurricanes, they generate right off the coast of Africa, and they follow an easterly path right until they reach the Caribbean region. So that is one of the reasons why the pressure gradient force, even though it can be on a global scale, if you were to narrow it down to the more regional scale, this zone actually affects us 24/7 right throughout the entire year. So if you were to even look at this global picture over here to the right, you will see in that zone you have a lot of unstable conditions. So at times of the year, and especially during the hurricane period, we have a lot of heavy rainfall and thunderstorms that generate during this movement. So if we were now to look at it on a more local scale, meaning within your own island or within your country, one of the factors where you can look at is now land and sea patterns. And land and sea patterns exist due to the complex climate interaction between the temperature that is distributed over land and water, and then it depending on the topography of that land. So in the summer, what you will have is a low pressure center being forming over land, and then warm air is drawn towards the location of the land. And in the winter, we have the reverse. So that heat that is taking place over the land, it actually decreases and it flows outwards. So you can see the difference between the land and the sea patterns. It's actually very seasonal as well. So in different times of the year, you will find that your wind is originating more from the sea and also from the land, depending on what time of year. Friction. Now, it is, if you're ever on a flight and you are at cruising altitude, you will realize the aircraft, in a sense, is a little bit more stable at that region than when it is actually lower, as in when it's taking time to accelerate and move through and gradually increase its height until you're finding that cruising altitude range. And that has everything that has to do with it is with friction. In other words, the lower you are to land, the more turbulent wind is. So because of all the different interactions that are on the land, meaning the building structures, the trees, they will disturb that balance and that flow of air throughout the atmosphere. So, and the two types, there is one that is called molecular friction, and there is actually one that's called the friction between two surfaces. So more directly, friction between air and land. Looking at more friction, we can narrow it down again to just looking at the topography. So, sorry. What is it that exists within your island? Where is it that you think wind is at its best? Is it in front of a mountain? Is it before a mountain? So if you look at this small diagram here, just looking at some air motion, upon the mountain, you can see the air travels over the mountain and it's actually a little bit increasing the motion. So most wind farms within the Caribbean, they exist on hilly terrain, especially in Jamaica. Wigton Wind Farm is on hilly terrain, the other Blue Mountain Renewables, hilly terrain, the JPS Wind Farm, hilly terrain. They're facing on the top of the mountain. In other words, they have a more direct access to that more natural incoming air. As in, if you were below or after the mountain range, then you realize that the air becomes a little bit more disturbed. So that mountain becomes a shield. So it actually blocks the incoming air. So if you're in like a valley or in a plain that exists after a mountain range, you will find that you have less air motion. So in other words, it's less windy, it's a little bit more hot. And that's just because the mountain is behaving like a blocker. And that mountain wave is something that is actually useful for wind turbines or wind farms to extract. That's where you'll find good wind regimes within the region. And I keep going back to the region because, of course, in areas or in countries like Europe, within Europe, most of their wind farms can exist on very flat terrain, and that's just because their topography is much more different than ours. Their climate is much more different than ours. So another thing that we can mention is the valley breeze and the mountain breeze. So what happens within the day? What happens in the night? Which one cools faster in the day? Which one cools faster in the night? So during the day, the slopes of the mountain are warmed. So that air comes in contact, it becomes much dense and then it flows up the slope. Hence, you have valley breeze. And in the night, the reverse happens. The sides of the hills, they cool much faster. So the air between them becomes cooler, therefore it's dense and it actually drives the wind down the slope. And it's a phenomenon that takes place right across the region. Now, when you think about all the different factors that we have just mentioned, whether it be Coriolis, the pressure gradient, and friction forces, we can actually create an equation for wind. And the air motion via the Navier-Stokes equation is just for information purposes. It is not to give you any detailed mathematics or any derivation. It is just to show that we, as a source, as an energy source, and as something that happens naturally, you can actually quantify it with an equation. And this equation here is listed on the slide. So the rate of change of the velocity due to time, it is due to a pressure gradient force, also due to the frictional force, sorry, to the Coriolis force, and that is also due to the friction force. So everything that we just went through for the entire resource, we can quantify it by this equation. So the next slide that we have now is wind energy extractions, and I'm just going to run through and just ask, are there any questions at this moment? If not, we can take a quick 3-minute break just to refresh ourselves.
Thanks for that, Sanjay. There was one question. I don't know if you'd maybe get to it a bit later down. An anonymous person asked, what challenges have you encountered with the installation of wind turbines?
All right, so we will get to that later down, because that's the thing we're looking at within wind and the energy extraction devices. So so later down we'll answer that question. Just remind me in the next time I ask.
We'll note it. We have another question from Rolando Jalil, who asks, will there be any information on using LiDAR and SODAR for wind speed measurements and other characteristics?
Within this presentation, no, but I can mention it because it is one of the more newer technologies to gather wind data. It is a little bit more expensive than the ones that are mostly used, but it's also a bit more accurate. So it's a little bit more accurate.
All right,
So
cool.
it's a
So later down we'll
possibility.
get to that as well then.
Yeah.
Good. Now I mentioned there's a 3-minute break, so we'll kick it off again in about 2 minutes.
Right.
Meanwhile, we'll keep monitoring the chat. If there are any more questions, please post them. We'll make sure that we address them in due time.
All right, so continuing where we left off, just a short break. So now we're looking at devices that are used to extract the wind energy that we just discussed, as in how it came about. So the main extraction device that everyone knows about is a wind turbine. And what is a wind turbine? It's just a device that converts the kinetic energy within the wind into electrical power. And there are two main types. There are the vertical axis and the horizontal axis. Now, the more common of the two is the horizontal axis. It is the one that you will find on all commercial wind farms throughout the entire world and within the region. Now, how is it that a wind turbine capture the energy within the wind? From the Navier-Stokes equation, if you were to follow the derivation process and do some mathematics, you can do it in a sense where you can mimic that equation into an equation for kinetic energy. So the kinetic energy equation, half mv squared, you just put it right back there, you do some mathematics, you transpose for a mass, and then you can use the density, and you come up with an equation called half rho AV1 CP max. Now rho, as in the P here, that is the density, A is the cross-sectional area, V is the velocity, in other words, the wind speed, and CP max is the power coefficient called Betz limits, and that is at a maximum at 59.3%. So that is the most energy you can capture within a large mass of air in the atmosphere. 59.3% is the only amount that is usable. And in this case, it's the only amount that is usable to generate electricity. Within Jamaica, we have been analyzing, we have been looking at wind energy for quite some time. In 1996, actually, we installed the first wind turbine within the English-speaking Caribbean. It was done at a school, at a high school called Monroe College, and it existed on the hills of Santa Cruz, the Santa Cruz mountain range within Jamaica. And it's a mountain that actually runs parallel to the mountain that Wigton actually exists on, but in neighboring parishes. And then leading after that, we realized the potential for wind actually could continue. So an analysis was done across the island, and it was a couple of sites were looked at. But in the year 2000, Wigton was the site, Wigton, that is, the location that we're here at now, was selected for implementation of wind turbines for phase 1, that is. So in 2004, the commission actually completed and started generating electricity. Then we looked on the same site and we expanded. We brought in 9 turbines, so we brought 18 megawatts of power onto our previous total capacity, and we brought it up then at the time to 38.7 megawatts. And then JPS in 2010, they decided as well that they had analyzed enough data and had done their paths and done their wind resource assessments and could also as well install a wind farm, and they did it in the neighboring mountain range, the Santa Cruz, and they installed a 3 megawatt wind farm, just 4 small wind turbines. And then we had a 6-year gap where we did more analysis, so that was when the IDB wind resource assessment took place from 2011 up until 2014. Wigton phase 3 came on board. We added 24 megawatts of power, and then also BMR, Blue Mountain Renewables, they added 36 megawatts of power in the neighboring parish, St. Elizabeth, on the St. Santa Cruz Hills. So in Jamaica, we've been in wind energy for some time. We've done it, and we have an understanding as in what is it that is to be done for the implementation of a wind farm. within the Caribbean, and especially some of the member states of CARICOM, we know that there is ongoing discussions, ongoing analysis to see when is it that a wind farm can be implemented in some of the countries. So like in Belize, we know that there has been a wind map that was produced to highlight just some of the stronger areas of wind energy, wind resource. In Guyana, the GEA, they are doing some wind measurements at Kato and Quarry, and they mentioned they'll be taking some measurements at some other locations. In Trinidad, they continue, even though it is energy-rich country, not in the sense of a conventional means, they still have dialogue. They want to do an island-wide assessment of the potential across the two islands, that is Trinidad and Tobago. And just to look at some of the maps that were produced, we see where in Guyana you can see some of the hot spots in terms of wind energy. Where is it that there's a strong potential for wind energy development? If you were to look at Belize, you can see some of the areas that they're highlighted. This was one of the previous maps for Jamaica. And if you notice section 2, section 3, that is where our current wind farms are located. So assessments are done, they're ongoing right across the region just to see how much further we can take renewable energy integration within the grid. So as expected, wind energy or wind speed, it is crucial for energy generation. But if you remember, if you were to look back at the original equation, half rho cross-sectional area multiplied by the velocity q, you will see that there are other factors that are involved. So the fact that you have density as a factor, that means now you have to take into consideration the temperature of the area and the different air pressures that is surrounding. And how is it that you can quantify this as a means? How is it that you can look at this or gather this information or gather this data? How is it that can you use this data now to go ahead forward to make the plans that is necessary for us to implement a wind farm, or to say that, okay, we did our checks, but this area is not suitable for wind energy developments. Now we look at wind resource assessments, and of course I will pause again for a couple minutes just to see if there are any questions or if anybody have any comments.
2 questions came in through the Q&A, Sanjay, both from anonymous. First
Sure.
one, are there any utility-sized wind energy turbine plants located in the sea anywhere in the Caribbean?
No, not that I am none that I am aware of. There are, I think there's only one that is close by to us, and it was recently done, and that is actually in the States, near Rhode Island. They have just implemented, I think, four large-scale wind turbines. That's the closest offshore wind farm I can think of. The majority, of course, it exists within Europe, within the seas and within the oceans that are surrounding European countries.
Okay, just a quick follow-up from me. You had mentioned roughness before. Is the whole idea of wind turbines in the sea that the sea is smoother so you get better winds over them?
Because there's less interference from land, meaning land structures. And it depends on what sea or what ocean you're looking to implement the wind farm. So the fact that there is not many interferences from a building within the ocean or within seas, there is less turbulence that can affect your turbine's output.
Makes
sense. Hence, you find much larger turbines offshore, much larger compared to onshore wind farms. Their turbines, they can extract a lot more energy from the wind compared to onshore wind turbines. That is where the limitation takes place for onshore wind farms when you compare it to offshore wind farms.
Understood. Second question also coming from anonymous, and
Sure.
It's maybe a little bit outside of the scope of this talk, but I think you'd know how to answer it. The person's asking really a legislative question. Can you explain what are the legislative requirements which needs to be in place to facilitate the use of wind turbines?
Well, I can't answer it now, but I think I have it mentioned further down within the presentation. So if you want, but some of, all right, let me just mention some. So some of the legislative structures that you have to go through is one, environmental impacts. So you have to do that pre-installation of any wind turbine. So while you are measuring the resource, one of the key things that you do is reach out to the various stakeholders. So the environmental agencies within the different islands, the different countries, you will reach out to them first and say, all right, we are undertaking such a project. This is what I have in mind. I'm looking to install a wind farm here, but initially I'm going to quantify the resource, I'm going to measure it. But while I'm measuring, could you come and do some assessment of the land area? What is it that is protected? If there's any protection within the area, is there any wildlife? Am I disturbing any habitats? Stuff like that. So mostly your environmental agency would be the key point here. And then you look at the land agency as well, the different land agencies within the islands. So those are the two main points of contacts first, the environmental agency and the land agency. So after you go through those, then you look at, you look at then how you impact the surrounding communities. So now that is where you get the councillors or the different townships involved, or the different parishes, wherever you are. So that's a quick answer for that question, but we break it down a little bit further as we go along.
Okay. I see another question just coming, which I think touches on the answer you just gave. The person was asking if you address some of the challenges such as noise pollution and other factors where public oppose wind turbine plants. So you're going to touch on that later.
It's the same thing. Yeah, same thing. You have to go through the different agencies and you have to measure it, of course. I saw the next question published, but I've not seen it. Could you, it went. I think it was, they were asking, wind, how is it that you quantify it at hub heights? Well, we are going to touch on that within the next scope of the presentation, which is the wind resource assessments.
Very good. Not seeing any other questions coming at this time, so maybe you want to proceed there, Sanjay?
Yeah, so I'll break again for 1 more minute and then we proceed again.
Very good.
So 1 more minute. All right, so but before I continue, so our next question just came in, and I think they're asking in relation to the assessment dealing with birds and bats. We also will touch on that later down, but it's the same thing. We have to get NEPA, the environmental agency, involved, and normally before pre-installation of the wind turbines and after, NEPA will come and they will do bat or a bird survey to see what flight animals are in the area and how often they're in the area. And then every month we have to, us here at Wigton, we have to submit a document to the environmental agency to say that if there were any deaths of birds that took place within the month period. And of course, being a wind farm, we are susceptible to any birds hitting our blades. So it is something that is unavoidable. So if we do analyze the area, after we analyze the turbines every month, so we drive around to each turbine, we look at the surrounding area to see if there are any birds on the surface, the earth. And if we do, we log what type of bird or what type of bat, and then we log the date we find it, and we submit it to the agency to say that this number of birds were killed in the process, or there were no birds that had passed during this month. But we have to submit that report every month to NEPA. And likewise, it should more or less is the same for different wind farms across the entire region or the world. So I hope that answers the question. So I will continue now with the presentation where we'll now look at wind resource assessments. So the main thing that we are here today is actually looking at how is it that we undertake our wind resource assessment. What are some of the key steps that are involved? How is it that we can analyze the data? How is it that we can put together reports? And the intervals, the different intervals of reports. How often should we do a report to your different stakeholders or to your financial agencies, whoever is it that is a part of the entire project? So the first key step that we're looking at is how is it that we prospect the site? Some of the first thing that you do is that we go to the initial site that is selected. What do we look for? How is it that we can tell that, okay, maybe we can measure here versus not measure in a different location, stuff like that. How is it that then we collect this data? How is it that we can now manipulate this data and present it to our different partners to say that this was the findings for the past 6 months, this was the findings for the past year, stuff like that. And then we also look at a met mass assembly. So the key feature of a met mass, it is the main structure that houses instruments that are needed for data collection. So if you remember earlier when we were looking at where is it that this wind resource came from, how is it that the wind here in Jamaica is different from the wind, let's say, in Germany, or why is it that the wind that we're seeing now in the entire region is a little bit strong? Know what is taking place within the atmosphere. We look at prospecting. So how is it that we can just go to an initial site, or what is it that is in existence that can help me to select a different country or to select a particular area within a country to say that I think this area has the potential for some wind energy development. Now, if we were to look across the entire region, and I will share with you guys a next screen after this slide, what is it that is taking place that can help me or that can assist me to say that some wind energy potential exists across my area? So first and foremost, we know that our winds in the Caribbean, it originates from the northeast. So what is it that, or how is it that it is from the northeast? If you remember, we can go all the way back to the ITCZ. Where does that originate from? That intertropical convergence zone, and what does that zone brings? But then we can also look and remember what is it that happens within surrounding oceans or surrounding seas. So the Atlantic Ocean or the Pacific Ocean. And one of the things that we're going to quickly look at is our website. And I invite everybody to just open this website. It's actually a free website, and it's actually a very fun website to look at and use.
Can you drop the URL in the chat link? In the chat
Sure,
there?
I will do that. Chats right here. And it was sent. So here we have a website called windy.com. It's a free website. Anybody can use it. It's very interactive. And one of the good features of windy.com, it is something that shows the current wind patterns across the region up to the hour. So it has a lag of 1 hour, and that's just because it's pulling data from various airports, and it takes it the models, the different computer models that they use at Windy. It takes them at least 1 hour to generate or to do some forecasting. So what we're seeing now is what is taking place across the region. Now, across the island of Jamaica, the wind is actually really strong today. But we can look and we can understand and we can see why is it that it's strong, and you can look through the entire, what is it they can highlight. So there's something called pressure level. I can highlight it, and then I will display the pressure. And I'll zoom out just a little bit. And then I'll also show the pressure particles. Now remember, and always remember, wind moves from a high pressure to a low pressure. So we have a high pressure system existing so a little bit north of the region, and that is feeding to a very strong low pressure system that we see here taking place over the United States. And that little low pressure area that you see right there that is existing over the States is actually a snowstorm. So if I were to switch to rain and thunder, or in other words, some precipitation, or if you were to even pay attention to the different weather news that is taking place across the states, you will hear a lot of people currently complaining of how cold it is right now in different, especially in the northern part of the United States. So, and also in certain areas of Canada. Now, that low pressure system that is taking place over the states is what is driving this high wind that we see across the region. And I think the wind is actually high across the entire region. So not only Jamaica, but in Barbados, Trinidad, the St. Kitts and Nevis, all the Eastern Caribbean islands. They should be feeling this very strong wind regime currently that we are facing across Jamaica. And it's just because of that snowstorm in the States. So remember, as I said from before, we are existing here within the Caribbean on a regional scale, but what is affecting us right now is something from a global scale. So even though we may think we're far from an area, what is taking place globally does affect us as a region. And you can zoom out a little bit more just to see the different interactions of the pressure systems that are taking place right across. So this high pressure is driving and creating a lot of wind rotation and feeding this low pressure system, hence a snowstorm across the states. And now that cold front that is just extended along the coast of the eastern part of the United States is actually moving closer and closer towards us here at Jamaica. So within the parish of Manchester and St. Elizabeth, there are some of the cooler parishes here. And this morning we were experiencing temperatures of 18, 19 degrees Celsius, which is a little bit more chilly than what we're accustomed to. Yes, the parish is actually very cool on average, but today is actually one of the more cooler days. And that's just because of the snowstorm that is taking place. So, but this, as I said, it's a free website. It's easy to use, it is fun to use, it's very interactive. You can look at the different aspects. Remember the temperature graph that we had earlier? It's no different. You can look, it's very interactive, it's very fun to use, and the fact that you can forecast, you can have an idea of tomorrow's temperature, tomorrow's wind, it is actually very usable depending on what is it that you want to do. So here, us here at Wigton, we actually use this graph or this website every single day to monitor or give us an idea of how is it that we can go about in planning our jobs. So large scale jobs that we have, we couldn't do in wind like this because it's too high. So it'd be very risky. So if you were to ever install a Met Mass if you were to implement a wind resource assessment and you reach the Met Mass implementation stage, this is a very good website to look at prior to you installing the Met Tower, because a Met Tower, it cannot be installed in winds like this, which is really high. So Windy will give you an idea of what is it that is going on within the region and when is it that you could gauge. So you could, as I said, you can forecast. It gives a nice idea, nice visuals that assist within your forecasting or within your planning for your projects. So I will then switch back to the presentation. As I said, it's free, so it's a really good website to use, and it's very interactive. I'm switching back to the presentation. Just give me a second. Okay. So after looking at a wind regime on a regional scale to see what it's like, and if you say, okay, I think some wind energy development can take place, you can then narrow it a little bit further. So here, looking at the map of Jamaica, this is just a topography map. And some of the more hilly interiors here, where that red arrow points at, that is where Wigton exists. And the neighboring mountain range, the Santa Cruz mountain range, is the one that exists to the left. That is where all the two wind farms exist, on this range. But you can see, just looking at the map, you can see that there are other areas that may have the potential. It may not be feasible, but it does have the potential for some wind energy, or it does have a high wind regime at those locations, based off what is it that we see here at Wigton, based off what we see at the Santa Cruz Mountains. So if you think about the wind and where the wind is coming from, the prevailing winds from the northeast or from the east, once you're traveling alongside or you're increasing along that mountain range, as we discussed earlier, what we call the mountain wave, if you were to have a wind farm on the top of a mountain ridge within the Caribbean region or within Jamaica, more specific, that is where you extract the best wind regime, as long as it's feasible. And keep that word in mind, feasible. Now, once you see or you're looking at your map and you have an idea, so maybe I could check out the parish of Manchester or a different parish. I know this is using Jamaica as an example, more or less it's the same for whichever island state that you're from. So after looking at the map, you say, okay, maybe Manchester could have some wind energy development, or maybe St. Elizabeth. I can go now a little bit further and visit these places. So I will drive out, we will take a day, we go to these locations and then say, okay, we are here. What is it now that can tell me that there is a strong wind regime here? And you just look at the trees. And this phenomenon is what you call flagging. Now, once you have a consistent wind regime or consistent wind direction, and in our case, from the northeast or from the east, your trees or the branches on the trees, they will bend into the opposing direction, and that's just because of how strong that wind regime is. So if you were able to visit Wigton, we have quite a numerous amount of wind flagging that is quite visible across the entire area. So that is one of the main indicators that you use to say, okay, the wind regime here is actually really strong, and based off what I am seeing, I can see that my wind my trees are bent in one direction and it's bent enormously. And then you have different levels of flagging. So if you were to go and look at what is it that you see a tree, you could use this slide here as a guide, where if you were to visit a location and you see a partial throwing, so you see like a category 5, you'll see that that wind speed is between, that annual wind speed is between 7 to 8 meters per second. And then that would be a very good indication to say that, okay, at 7 to 8 meters per second is actually a good wind speed for future wind energy development here. So maybe this location, if the land is accessible, if the land is good, I could actually look into analyzing this site right here. If you have something like carpeting or complete throwing, anyone over category 5, so partial throwing, complete throwing, or carpeting is actually really good for large scale wind energy developments. Now, if you're looking at it from a residential point of view, you could use moderate or even complete flagging, just a little bit, because then your smaller wind turbines can account, or they can extract your wind energy at a much lower speed and still be beneficial to be used within your residence. So anywhere from moderate to complete is what you could use for residential purposes. For large scale purposes, you want something partial or more. So you can use the index of deformity within the slide. Now, the other thing now what you have to look at now is your location. So you have visited your location, you have seen some flagging, you have seen, okay, then you're satisfied with the level of flagging that you have seen. You then ask yourself, can I or should I put some instruments here so I can quantify this wind, so I can measure this wind, so I can analyze this wind? You then ask yourself, where is it that this land exists? So is my land, or is the land that I'm looking to develop or to turn it into a wind farm, am I existing within a commercial area? So am I in a town center or a city center? Am I on farmlands? Am I a little bit outside of some community developments, or am I much rural, or am I existing on way high mountain terrain? How far am I from my civilization? What is it that could disturb me? So if you remember, I pointed out earlier, some countries within Europe, their wind farms exist on very flat terrain. And that's just due to the climate features of those countries, and how is it that their countries interact with the ocean temperature surrounding them. They have that ability for their wind farms to exist on very flat lands. But you will find also that most of the wind farms over that side of the world, they're not necessarily near much large town centers or commercial entities, because then you have to now take into consideration, how is it that you will move your large scale, your large parts, your wind turbine parts, how is it that I can get them from point A to point B without being that much of a disturbance? So when you're looking at the wind gradient here on this graph, as we know, the higher you are in the atmosphere, the stronger it is the wind, or the better is it the wind regime. But here you're looking at, there's a particular feature here that says Z0. I'm not sure if you're seeing me highlight it, but if you look at Z0, where it's between highly turbulent 3D, that is now where you're going to know the roughness of the area, the roughness sublayer. But how is it that can you measure that roughness sublayer? How is it that the area that I'm looking to measure, how is it that I can tell, or how is it that I can give it a value to say that this is the roughness value of what exists and this is how it will affect the wind energy? That is it that I want to develop here. So we look at it a little bit more, we will break it down a little bit more. So if you were to look closer to the seas, so we have 3 different wind gradients here. We have one within a town center. We have one that is close to existing, like on like farmlands, and then we have one much closer to the sea, or right on the sea, in fact. And if you look at the graphs and look at the spread of the graphs, what you want here is a much wider gradient when you're comparing to your focal point. So if you're there at a location and you are looking at, in other words, you do a 360, you just turn around 360. The wider the focal point from where you are, the better it is for you. Hence, offshore wind farms, when you're standing in the ocean and you do a 360, the only thing that you're seeing is ocean. There's not many disturbances in the ocean that will allow for a decline or a decrease in the width, in the gradient, in the width of the gradient wind. Versus if you're in between the two, so you're a little bit close to the sea, but you're not too close to a town center. You also have a good feature there. You have a good amount width, and then you do a full 360 at your location. You can say, all right, then maybe I can see a building a couple miles far from me, or I can see trees or shrubs, but they're not that high. Or versus I'm in the middle of a town center. So if I'm in a capital like say a Bridgetown or Georgetown, whichever, and you do a 360 and you see buildings and buildings, and it's maybe even though I could put a wind turbine here, the fact that I can see these wind buildings in my eye line or in my vision, these will affect the output of my wind energy. What is it that I want, or how is it that I want to increase my output within the grid? So those are some of the basic things that you do first. When you approach any area to analyze, you look for the flagging, and then you also identify what is close to me, where am I, what is it that is surrounding me? Am I close to, am I in a town center, am I in a city, stuff like that. Those are some of the questions that you ask. So once you find a location that you think has satisfied you, in other words, there's a good amount of flagging, there's not much developments within your 360 that you did, then we can look at how is it that you can now measure this data. So this is also now where I will break for a few. We will answer some questions if there are any, and we'll break for a few minutes and then we continue. So do we have any questions?
Thanks, Sanjay. I think there are a couple more questions that came in around the whole bird issue. Someone asked specifically, what has Wigton's experience been with environmental concern that birds and our bats getting killed by the blades? To what extent has that occurred at Wigton over the years? And further from Ronaldo Jalil again, has Jamaica considered ultrasonic device attachments to wind turbines to keep away birds and bats?
Yeah, so we have experienced some interferences from birds and bats. As I said, I do think any wind farm is not susceptible to this. And we do log the report monthly, and as I said, we submit it to the relevant environmental agency. In terms of damage to the blade, there has not been much because the bird compared to the blade is it's a lightweight compared to a heavyweight. If we have looked at attaching ultrasonic devices, we have in our newest phase 3, they have a number of ultrasonic sensors that exist that will, I think it provides a feature where once a bat is incoming, it keeps sending out a signal that should keep away bats because of their ultrasonic feature. But from time to time, it has reduced the number of interferences, but it is not a perfect system. So every now and then we will have a casualty, meaning from the bats or birds. But it is not something that happens frequent on site. It is not something that happens every month or every week. It happens, but not frequent. Not frequent.
Okay, good. I think that's it for questions. Oh, hang on, here's another one.
Sure.
There was a question regarding whether Jamaica is going it alone in terms of investment, or has the Caribbean been invited to participate? This was from an anonymous person, and Penny conveyed it. To clarify that question a little bit, it wasn't quite clear to me whether the question was, have other Caribbean countries been looking at wind, to which I think the answer is yes.
Yes.
Or whether it is that Wigton is looking towards other Caribbean countries. Not quite clear, that question, but invite your take on it nonetheless.
All right. So if other Caribbean islands are looking or analyzing wind, as I mentioned it before, yes, they are. Is Wigton looking to other Caribbean islands? And yes, we are. As we are no longer a government entity, we have recently become owned 100% by shareholders. We're listed on the Jamaica Stock Exchange. We are no longer constrained to just operate within the island of Jamaica. So we as a company, us here as a company, we are looking region-wide. As in to any other developments outside of that, I cannot mention, but we are looking region-wide.
Excellent. Anonymous asked, would a hurricane greatly improve energy output from a farm, or would it overload the equipment and cause failure? Take a category 3 hurricane, for instance.
All right, so hurricanes on a whole are a detriment to any renewable energy development, and detriment in the sense that once you have an incoming hurricane, the chances of you operating your plant is non-existent because we have a grid provider. So we have to listen to what the grid provider says. And in this case, and in Jamaica's case, the JPS. So if the hurricane is imminent, JPS will remove some of the IPPs on the grid. And in this case, Wigton is an IPP, it's an independent power producer. We will wait until what JPS tells us what to do. So if, as I said, if the hurricane is an imminent threat and it's going to be a direct threat, JPS normally tells us to stop producing because they will reduce their load within the grid. Okay. And they will, and that's right across the entire island. So they'll ask different IPPs just to stop producing. So once Wigton stops producing, what we as a company do here is that we then go into protective mode. So what we do is we will visit all the wind turbines. We will either lock the blades or lock the hub. And that will protect us from the turbulent forces from the hurricane. And then once the hurricane passes through, we will visit site. We will assess damage, if there's any, and then we wait on JPS again to say, okay, we can repower and continue providing power. So it is not a case where if a hurricane comes, we make a lot more power, we produce a lot more energy. It is a case where we have to listen to the grid provider.
Makes sense. I think that's it for questions at this time. So you want to continue with the break?
Yeah, man. So we continue again for our next 2-minute break. If any other questions pop up in the break, I'll answer them when we return, and then we just jump right back into the presentation.
Very good. Stretch your legs, people.
All right, so we're back again, and if there are any questions, I'm not seeing any. So I think we can. Were there any?
There are two that are coming in, and I'll push them through now.
Okay,
First
sure.
one is, if during a hurricane you'll have to shut down operations, how can a wind farm become more resilient in the face of hazards?
All right, so normally your turbines are manufactured to withstand up to a certain category hurricane. So it all depends on the manufacturer in the sense. So if it's a case where you're in an island state that is a little bit more exposed, or you have more frequency of hurricanes, you can suggest it to your manufacturer. No, well, not suggest. You tell your manufacturer that this is the case here at the site here, and these are requirements that I would want you to take into consideration in building our wind turbines. Also, you could look at the foundation structure. Most of the structures for wind turbines are rated up to a certain category. So those two are the main things that you look at: the structure, meaning the foundation, and the manufacturing of the turbines.
Okay, very good. Multi-part question coming from our resident power engineer, generation expansion engineer. First, to the hurricane question, what is the strongest storm that has hit Wigton assets? That's first. Second, what are the assets built and rated to be able to withstand in terms of wind speed for Wigton? And three, could you touch on the examination post-hurricane? Is it only visual inspection, or are there other tests carried out?
So, all right, so 3 parts. So the first part is in 2004, if we remember correctly, Hurricane Ivan, it impacted the entire island. So Wigton initially, we went through Hurricane Ivan. There was, I think the most that took place was just a little damage to some of the nacelles. The nacelles are the top parts, the top of the wind turbines that has all the major components within. So at the time, I think the covers of the nacelles were more for European countries. In other words, they were tight, as in once you close them and once you lock them, they were not as rigid as how we had suspected them to be. So some other turbines, they had a little water inside of the nacelles. But outside of that, the blades were good. And then the turbines in the cell, they stood up. And I think they went back into operation just a few more days when JPS said, okay, it was ready to come online again. And I think the second part of his question was, could you remind me? I think I just remember the third part. The third part was what are some of the tests that we took?
The second part was, what are the assets built and rated to be able to withstand?
Yeah, okay, right. So Wigton, they're rated up to category 3.
Okay.
Well, it depends on phase. I think phase 2 was rated up to category 4, but phase 1 was category 3.
Okay.
But phase 2 came.
What category Ivan was again?
4.
Yeah.
Yeah, 4. We are very devastating hurricane. We also had Hurricane Sandy, but that only affected the eastern section of the islands, but still the winds were felt across the entire island, but there is no damage then.
Okay.
And then the test that was taking place, that took place, not only a visual inspection. So after hurricane has passed, we do visual inspection, then we do tests. So we go back inside all turbines, do the various checks, just to make sure that everything is okay. So we actually visit inside and go up tower, and just to look around, do some electrical tests to see that all is working and working fine.
Just electrical or structural too?
Electrical and structural and visual, both.
Okay, good.
So we look around the entire turbine base just to see if there are any cracks or any of that sort. But that normally is highly unlikely, but we still look. So it's
understood. One more question coming in from Rolando Jalil. In regard to preparing for heavy winds, tropical storms, and even hurricanes, have any wind turbines been installed with a mechanical raising winch system at the base to lower the wind turbine to the ground and bring it back up after the danger is over, also for easier maintenance?
No. Commercial wind farms, or well, commercial wind turbines, they are rooted into the earth. So there is no lowering of a wind turbine taking place. That only takes place for residential wind turbines. So lower classes of wind turbines. So
commercial ones are just too big and too heavy, right?
It's too big, too heavy, and the cost, it wouldn't be feasible for you to lower the turbine. Hence, they are rated for the hurricanes. They did the test within the different devices. You call it a wind tunnel. So you normally do a test with the different blades within a large wind tunnel, just to make sure that once you reach at the hurricane speed or over hurricane speed, to see the effects or see what happens with the blades. But for residential wind turbines, those normally exist on poles, and they use guy wires as their securing mechanism. And those are then rooted into maybe a ceiling or your earth, but those allow for the lower, not large scale ones, not the ones here at Wigton or any wind farm, to be specific.
Okay. There was one more question, and then I think we should continue. Read more of a comment. Person says, I'm assuming your turbines are upwind designed with a yard drive to enable the turbine to face the wind. Yep. And is it not safe to say that it's not the power company that drives operation under hurricane conditions, but you yourself need to park the turbines for safety? Which yes, I think you did answer that second part.
Yeah, right. So another thing I could add in terms of the safety for the hurricanes is that there is a position for the turbines, and we call it the rabbit ears position, where we will have two blades in the air and one blade parallel to the turbine tower. So that allows for less vibration faced by the blades, by the hull. Hence, the tower will act as a shielding mechanism.
So okay, so it's like a straight line up and down.
Right. So we'll put all the turbines in the rabbit ears position. So it's like a Y, which is very even, and the lower, the perpendicular part of the Y runs parallel to the tower.
I get you. All right, I think that's it for questions and comments for now. So back over to you, Sanjay.
All right, so now we move forward into the wind data collection. So after looking at where is it that this resource comes from, after looking at how is it that we can tell this area is more than likely feasible for some wind energy development, we look at how we can now collect this data. So the main thing that we use for any wind resource assessment, one of the main things that is used is something called a meteorological mass, or a met mass, or a met tower. And it is made of steel, and you house or you put instruments on that instrument. Now, ideally, you want the net tower to have a similar height to the wind turbine where you're going to install it. But let's say a taller tower is not feasible for you, as in you do not have the capital expenditure to do that. You can purchase a smaller net tower, and then you can use mathematics to give an idea of what is it that wind speed is at the height that you need that. But we'll look at all those mathematics later. So some of the equipment that you find on a net tower, you find, of course, anemometers, and you will have several at different heights. That's very important. You will need wind vanes to record the direction of the wind. And if you remember the equation from the previous slides, remember density, how you quantify density in measuring, you will need a thermometer to measure the temperature, you will need a barometer to measure pressure, and of course you will need a logger to store all this data. Sometimes at some metal you will find a solar panel there, and the key feature of the solar panel is actually to provide power to store the data from the instruments. So it becomes a little bit easier. Back then, before solar panel usages, it used to be battery operated. So you will switch out the batteries every now and then after a time, but what you will find is that you will have a loss of data collection. So, because you're not sure when is it that this battery will die. So with the solar panel, you will have a battery being charged by the panel, and then that panel and that battery sends the electricity that is needed to the instruments to record the data within the data logger itself. How is it that you erect this met tower? Depending on the met tower, of course, there are normally two types. There is a tubular type and there is a lattice type. I will look at it later. But if you have the tubular type, which is a very slim cylindrical structure, you will use a winch with a gin pole, and that will act as the base of the structure that will do the lifting for you. And of course, you'll have different personnel on the ground assisting in the securing of the tower, just to guide it while it is being tilted forward. Hence why I mentioned earlier that you cannot lift a met tower within high winds, because it becomes a little bit difficult. It's the same for installing a wind turbine. Once the wind conditions are too high, it is not possible. You will actually just wait until that air or that period of high wind has passed. And this is where the windy.com would actually come in place. You use windy.com or use whatever other map or website that is available to just give you an idea of what the wind would be like in the upcoming days. So in some met towers, as I said, some of them are lattice, and some of them you do them piece by piece, or some of them you attach or you form on the entire ground and you tilt with a gin pole. And you use a winch, a manual winch or a motorized winch to do the lifting while you guide it with personnel on the ground. So in these two pictures, you will see that we have two guys anchoring the tower while the winch is doing the pulling, and it's pulling the gin pole, which then pulls the tower up forward. In the other picture, you'll see it's a lattice structure, and that is the base of the lattice. Normally for lattice, after you pull up the base of the lattice tower with a gin pole, you then have guys that go on tower, and they will pull them up piece by piece or section by section, similar to how a cell tower is actually erected. From a side vision, this is how it looks like. You will have the entire met tower, and once you're assembling your met tower, especially if it's a cylindrical one, you put on the instruments while the tower is flat on ground or it's a little bit raised off ground. Your guy wires will be already they'll be already cemented probably like 2 weeks from before, and they will just have the guy wires running through as a securing mechanism. And looking at the 90-degree angle, the lower one, of course, that is the gin pole. And what is not shown in the picture is your winch. And I said, sometimes it's a motorized instrument, sometimes it's by hand, and it's just a rotating mechanism that reels in the guy wires that is attached to the gin pole. Your finished product will look something like what it is to the right. You will see the guy wires, you will see a perpendicular met tower that is situated 90 degrees to the earth. And you will see the data logger, which is a small black thing way down to the lower part of the picture. And of course, you'll have the different instruments. Now, some of the instruments that are used within the met tower is, of course, the anemometer, and it just measures wind direction. And of course, you have different types of anemometers. You have the vane types, you have the regular 3 cups, and of course, one of the newer types is the ultrasonic anemometers. Depending on your cost, determines which anemometers you use within your met tower. If you have the expenditure, you have the capital cost to acquire ultrasonic anemometers, you could. If you want to implement a LiDAR system, you could as well. So it all depends on the cost. But the more cheaper of the 3 or of the 2 is the cup anemometers. We'll have wind vanes, of course, and wind vanes, it will just indicate the wind direction. And the wind direction is very important because if you were to have a site that is not necessarily in a very strong predominant area, and you have a wind vane that keeps rotating throughout the times of the year, as in it is not predominant, then you can have an issue with whatever wind turbine you will implement, because then you'll have a bit more strain on the gears whenever it's yawing. You have different sensors now. You have the temperature sensors and the relative humidity sensors, and of course you're measuring with relative humidity how much water vapor is within the atmosphere. And that is very important, because if you were to have a wind farm that exists in a very salty atmosphere, like us here in the Caribbean that exists within the Caribbean Sea, that can have a little bit of wear and tear on your different instruments or your different components within the wind turbine. So then you'll have to ask the manufacturers to use anti-corrosive paint or to have a little bit more anti-corrosive mechanisms on the different gears or the different components within the turbine. Your pressure sensor is just there to measure atmospheric pressure, sorry. And these are some of the things that you need to actually calculate the density. And remember, density is a key part of that equation that is needed to extract the electricity from the wind energy. Now, all this data has to be stored somewhere, and in this case, it's a data logger. So your data logger has to be sealed. In other words, it needs to be waterproof, so it doesn't allow for any rain to interfere inside. You would preferably need a remote power source, and normally it's a PV panel, a solar panel. And this is just to prevent you from visiting the site too often to replace batteries, so that you can have a consistent collection of data. Within the industry, it is normally 10-minute data averages, and the collection of the data, and since lately, as of in the later 1990s, started and ongoing, the data collection is done via GSM modem, normally a similar setup to a cell phone. And what it does, it emails that data file every single day at a particular time that you set. And it normally allows for manual recovery via USB or SD card. So in the case that the cell service has failed maybe for 1 or 2 days, that data is still stored on the logger, but it can be recovered by USB. And normally what happens, once you have cell service being recovered, the data that was already stored will be sent. So it minimizes any data loss. Minimizes the lot. So how much data is collected within a year? So if you were to look at the wind speed, direction, just some different averages, you're looking at over 5 million different values. It sounds a lot, but you can quantify this data, as I said before. You can use different tools and different graphs to analyze this data. Now, some of the graphs or some of the tools that we can use, especially for wind direction, we can use something called a wind rose. Now, a wind rose determines the frequency of the wind directions and how intense the wind is within that particular direction. So in just looking at this diagram, you can see the color scale. So it's telling you that the purple or the darker purples are the more stronger wind speeds, and they tell you what percentage it does exist in the northwest. Now, this is not for the region, this is just an example, just giving an idea of how is it that a wind rose looks. So you can see the more lower of the wind speeds they exist, they don't have no preferential direction, but you realize as you get a little bit stronger, there's a little bit more preference to the west. So if you just a quick analyze this wind rose, you'll see that the predominant direction here is the US. Just a quick idea and a quick overview. And then I will break again for a few more minutes, and then we jump into wind data analysis. And then, of course, I open the chat to some more questions.
Thanks, Sanjay. There were 4 questions that I think divide into 2 groups, really.
Sure.
First was really about costs. People want to know what the average capital and operating cost would be to erect a met mast. And in particular, I think it was Kieran who asked the most detailed question. What's the average cost to erect and operate the meteorological mast at 80 to 100 meters in height, assuming a period of 1 year of data collection?
So I think that question actually encapsulates the other question, so I can answer this question only.
Sure.
The cost, it depends, of course, on where you are, but the fact that he gave some measurements, the last met tower that I had, one of the, and this is for temporary met towers, because you can have permanent met towers as well. But in this case, for assessment, to use temporary met towers. So in erecting, I had participated in a met tower construction. The price of the tower itself, it was, and this is just my my memory, because I'm not sure of an average cost. But from my memory, the cost of that metal at the time was roughly, between 10 to 12,000 US dollars, roughly. And
What year was that?
That was 2016.
Okay.
Yeah, 2016 in March to June, within that one, within those months. And that was an 80-meter height metal. And that was a lattice type, so it wasn't tubular. The instruments depends on the quality that you have. So you have different manufacturers of instruments. So one of the manufacturers that are closer to us here within the region is NRG, and they are from the United States, and you can visit their website, NRG, or just Google NRG, and they will give you a list of the catalog that they have. They have 3 cup anemometers, roughly 300 US for one. The wind vane, same price, 300 US for one. Similar, I mean, average price. I'm not sure what it is right now. And then you have a company that is, as I said, you have many companies, but I'm giving you the ones that I remember. So there's a company called Thies, Thies, Thies. They're out of Germany, and they're one of the more accurate in terms of recording information, and they're a little bit more expensive, of course. And their anemometers, they would normally start at between 500 to 1,000 US dollars, and same price for the wind vanes. Now, there is a preference to the size anemometers in Europe, because the renewable energy industry has been around for much longer than ours. Within us here, Jamaica, we have used a bit of both. So we have used Thies instruments, we have used NRG instruments, and Wigton has used both as well within the past. The different sensors that are involved, like the pressure sensors, normally those are between 800 to 1,000 US dollars. Now, in terms of manpower, and in terms of, I'm not sure of labor rates within the different countries, but whatever your labor rate is, you would need normally, if it's a tubular tower, you install those within 2 days. Normally you will install, you complete everything on the ground in day 1, and then you lift on day 2. So between a 2 to 3 day period. And for lattice structures that you install section by section as you go up, that could be up to a week. So whatever your labor rate is. Then you
How many people on a crew usually to install it?
Right, so it depends again on which type. So if it's a lattice type, meaning you install one structure, piece section by section, you need 2 guys on tower, and then you need at least a minimum of 4 guys on the ground. Minimum of 4. For the tubular type, you have nobody on tower, but everybody will be on ground. So that you require at least between 5 to 10 people due to the number of guy wires that you have to secure that structure. And then the other thing that you have to also take into consideration is your foundation cost. So whatever the cost is for your cement, your sand, and your gravel, and whatever, as I said, I'm not sure of the foundation costs within the different island states, but just know that you'll have to bear in mind the cost for cement, gravel, and sand.
So
And the
all in
quantity
it could
also
be
depends on the types, the type tower. Tubular types don't require as much mortar as lattice types. So you find that tubular types are a little bit cheaper in the capital cost. The lattice types are stronger, but if you were to have it for a year, my preference, and this is my preference, it would be for a tubular type. If you're looking for a 2 to 3 year period data collection, preferably go with a lattice structure.
I see. So all in, you're easily clearing 20 grand for
Yes.
construction and instrumentation.
You're looking at between 15 to 20, 25 at a high pack. So anywhere
Okay. What about operation once it's up though?
once it ups, it becomes a little bit cheaper. Because the only thing now you have to take into consideration is cell service. So like any regular data plan, you just need to send whichever service provider you have, whether it be Flow, whether it be Digital, or whatever exists. And I think it's only 2 within the Caribbean, if I'm not mistaken. And whoever you have, you create a contract with, and you just have a maybe 1 or 2 year plan. You pay a monthly bill, could be 10 US, 15 US, thereabouts. It doesn't require that much data to send it daily. You will also have costs, and these costs now will generate from the analyst side, but that is separate outside of the construction side. So between constructing and operating it, it only has the construction cost and there's not much maintenance to be done actually. So if you the good thing with a lattice structure, if one of the instruments fail, you have the ability to change its, replace it. You'll only think about that cost. For tubular types, it is not necessarily replaceable once it's in operation because of the height and because of the structure. Hence why we always install more than 1 anemometers on the structure. So normally you have up to 5 anemometers, 3 to 5 anemometers. You have 2 to 3 wind vanes, but you have 1 pressure, 1 temperature, and 1 relative humidity sensor, and 1 data logger. But the anemometers and the wind vanes, you have more than 1, always.
Okay, makes sense. Now, let me add up a follow-up question that's based off of a question I was asked much earlier. Somebody had brought up some of the more newer, sophisticated, more expensive instrumentation. Yeah. One, about how much extra would that cost? And 2, is there an advantage to using those technologies over a regular old cheap anemometer?
Because the industry within the Caribbean is not as new, well, not as old as the industry within Europe. For us, when we're creating different bankable reports, and it depends on the funding agency, of course. So your funding agency could be an international development bank. In other words, it could be an IDB, it could be a World Bank, or it could be one of your more local commercial banks. It depends on which entity you approach. They have their different regulations or their different needs within assessments. So within Europe, some more the funding agencies, they can require LiDAR because the industry has developed over a number of years and continually developed where they can look and accept LiDAR data collection as a bankable means. Now, that is not to say that the conventional way of collecting data, meaning the 3-cup anemometers, is not accurate. It is, but then you have to look at your budget. So if you have a budget, let's say you have a budget that there is no limits, and you were to implement some towers within the Caribbean, I would still suggest to you to go about the conventional method. Now, yes, the LiDAR is more accurate where you can get a little, because remember within the equation, wind energy is cubed. So a 0.1 or 0.2, they actually sound small, but they will make a big difference in terms of the energy extraction. So what you want is the most accurate data. But as I said, if it is a case where your budget there's no limit to your budget, then you could look into LiDAR. Will it make sense in the long run? Will it mean because I did LiDAR and not a 3-cup anemometer, or because I did a 3-cup anemometer and not a LiDAR, I will not get the funding that is needed? It depends as well on which financial institution that you approach. But more or less, the 3 cups, the conventional ways, they're still very, very accurate. And they're always being developed and they're always being calibrated, still accurate. So if you have an endless budget, you can choose either. If you are limited by budget, you stick with the conventional.
Makes sense.
But in terms of cost, LiDAR sometimes can be at least up to 3 times, maybe 5 times the cost of the conventional way, which is a metal way. So you can find LiDARs that can go up to maybe exceeding 50,000 and more. So it's just you to do your cost comparison to see which is it that benefits you.
All right, thanks for those, Sanjay. Now we have a bunch of questions around time for your data collection, all from Anonymous. Or sure. Anonymous is, not sure it's 1 or 3. What was the period of data measured for your project for Wigton? What is the recommended duration to obtain quality wind resource data at a particular site? And what time of the year is best to start the wind data collection?
All right, so I'm going to do it from the reverse. So the best time to start is in a period which is not windy. So for us in the Caribbean, if you remember that key slide with the ITZZ, that shift takes place in June. That is our windiest month in the entire Caribbean region, June. So you will not necessarily want to install a met tower within June. You will want to install it before June. So in one of the lower periods or the lower months before June, would be ideal to be installed. So leading up to June would be good to install. Within June, I would say wait, and then July or August, they're also, you look for a month with low wind speeds, or look for a day with low wind speeds. So you won't find much low wind speeds in the month of June. That much is true. In terms of the length, as in how long it is recommended for your wind resource assessment, whichever one you want to undertake. Ideally, you want more than a year. So you want at least 2 years to capture a full 2 cycles. So you want 2 Januaries, 2 Junes, 2 Julys, just to see what has happened or if there are any anomalies that have taken place within those time periods. So maximum 2 to 3 years, that is always good. If you don't have that much time, 18 months, but it has to be over a year. So 12 to 18 months, but over 18 months to a 3-year period is also good, is more ideal. But if you don't have that much time, as long as you're over a year, and more preferably over 18 months, you would be good. At Wigton phase 1, because the industry at the time wasn't that large share within the Caribbean, our data collection period, I think, lasted for 5 years for phase 1. And that was, I think it also had to do with the technology of the instruments And you, of course, had to account for some data loss periods. And that's just because of the mid-tower developments for the region. That is, as time went on by, so like for phase 2, an analysis was done because the land was there and they realized that phase 2 could actually be implemented on the same site as phase 1. Phase 2 had a data collection period of 2 to 3 years, 2 to 4 years, somewhere in there. And for phase 3, it was 2 to 3 years. So
thanks.
just keep in mind that you want to install in a month where leading up to June, so you can have a good amount of data from the month of June, and then you want to capture that data for more than 18 months. And for Wigton, we had 3 different periods of data collection, so we had a period for 5 years, a period of 2 to 4 years, and a period of 2 to 3 years.
Understood. We have another question coming in.
Sure.
Several parts of it, really. During the wind assessment, I assume the wind speed is not constant and there will be gusts or extreme wind speeds which are short duration. Does the design of the turbines or blades consider these extremes of wind speed? Also, how do you determine the minimum distance between each turbine to capture the maximum power output per wind turbine? The distance between to determine the effect of the turbulence on the downstream turbines that could reduce the lifespan of the turbine.
For the turbine one, I can answer that because, well, it's further down in the presentation, but just to give a quick overview. Normally it depends on your rotor diameter. So your neighboring turbine shouldn't be no less than 2 rotor diameters. So if the diameter of your turbine is 80 meters, then your next turbine should be at least 160 meters away. So that's the answer to the last part. To the first part, could you repeat the first part, please? Just remind me.
During the wind assessment, I assume the wind speed is not constant and there will be gusts or extreme wind speeds.
So,
and does the design of the turbines look at those extremes?
Right. So the analysis look at that extreme first, and then if the gusts that did take place during the assessment period were, it was not constant, but more just an instantaneous period, and your wind speed is also fairly constant, your turbines will take into account for that. They have systems in place within the blades, the pitching systems and the yawing systems. Those are in place to anticipate or to allow for any variation within their blades to maneuver that gust or that turbulence. But if you were to not have constant wind and have just strong gusts, once you do your analysis, then you probably would realize that the area is not feasible for the type of large-scale wind development that you may want. So it's 2 parts, really.
Okay, thanks for that, Sanjay. Seeing no further questions, and I anticipate the next couple sections will really shed some more light on what you just mentioned. So please proceed.
Right. So switching back screens. Okay. So after you've now collected some data for your different time periods over 18 months or however long you collected the data, now you look at how is it that I can analyze this data, how is it that can I display this data so I can understand what has taken place or what will take place if I were to install wind turbines. Now, some of the things, one of the key things that we have to look for is how is it that I can create a wind power profile. In other words, how is it that can I have wind that was measured at this location and quantified to my turbine height or my hub height, which is where I would like to know what is taking place there. You have 2 ways to do this. And one way is by using the wind profile power law. and where U1 and Z1, that is your known wind speed and height. So based off your wind, your met tower, and if you had a wind vane at the very top and you had one in the middle, that will be your the wind speed that was collected by an anemometer at the top will be U1, and then the wind speed that was collected in the middle, U2, or whichever way, it doesn't matter, it works the same. And Z1 will just be the heights. Now you will put it into this power law equation where you see that very Greek letter looking thing is an exponent, it's a function of atmospheric stability and the underlying surface characteristics. There's also a next law that can be used, a logarithmic wind law, profile law, and it depends on you, the person doing the analysis. You can choose which one you want to use. There's a value for Z naught in the logarithmic wind profile, and there's a value for alpha. And both these values you determine are what you use to find the surface roughness length. So if you had remembered when I said upon your initial visit to the site, you do a 360, you look around to see what is it that is within my eye scope, what is within my scale, and you take your pictures, you do your 360 pictures, you do whatever you need first. That will then tell you where or what is or what would be my wind shear exponent or my roughness length. So if you remember, it will be Z naught and the alpha. So if you're on a water surface, you realize you have very low shear exponents and very low roughness lengths. Remember that initial slide where we were looking at the width of the wind versus when you do your 360, if you're looking at the width as in what is inside. Hence water surfaces has very low roughness length and very low wind shear exponents. Open terrain, so you have a runway or airports, are also low because there shouldn't be nothing, any tall structure within that your eyesight there. Agricultural places, they have, you realize as you go further, with the more buildings, you have more large numbers, less interferences, lower numbers. These you actually use within the equations now to project. So in a quick example here, and we're using the power law, the wind profile power law. We did some met tower analysis where we want to measure or have an idea of what the wind speed would be like at the hub height, in this case 20 meters. We have H, 20 meters, we have H naught, 10 meters, we have V, which was collected over the period, that gave you 7.8 meters per second, and then we have a roughness class of 2. Now if you go back to the previous slide, a roughness class of 0.2, a rough class of 0.2. So we're within some agricultural land that have some houses and a little sheltering right shore. Hence, we can project to a wind speed at that 20 meter hub height at 9.5 meters per second. But as I said, it's just an example, but this is actually done for any and every assessment. And remember, wind shear, so small increases in wind give a large increase to available power. It is why wind speed in the equation is cubed. So 2 cubed will lead to 8. It's a much larger number. So any small increases in wind give a much larger output. So if you were to even think about it, if you were to double the tower height, if you were to have the ability to install a 200 meter hub height wind turbine, and this is just an example, not realistic, you could easily increase your power output by 25%. And it is that same reason why offshore wind farms, they have much larger wind turbines, whether it be in tower height or hub height or rotor diameter, it's way larger because their wind shear gives them that ability. Their wind shear exponent gives them that ability. Now, if we were to look in also at wind sharing, if we were to look at a radius, and it's a rule of thumb, for a radius of 1 kilometer around a potential site, the location obstacle should be no higher than a third of the height of the lowest blade tip. So if you look in the diagram to the right, at least a third of this height, it should be no higher. So you don't want any mountains that could interfere, or any shrubs or large scale trees that could interfere or disturb your wind patterns or your wind regime. You will try to remove, either you look for a different location, or you would try to remove such interferences, whether it be you may have to remove a little bit of trees just so you can allow for proper extraction of the wind energy. So our final topic, which is quantifying the wind data now for wind farm developments, we will look at. But before I go again, I pause for the next couple of minutes, and if there are any questions, I answer, and then we just wrap up the entire session and we go through some discussions.
Thanks, Sanjay. Just one question at this time. What's a rough figure, ballpark figure for the value of Jamaica's wind farm project? Or maybe it's projects that you'd want to speak of.
In terms of roughness class or total capacity?
I think he's talking about the cost.
Oh, cost.
Yeah.
Let me see. And the cost for Wigton too, I can remember that it was published at the time. It was around 60 million US dollars. For Wigton 1, I think it was around 20 to 40 million US dollars, and Wigton 3 was a little lower than 60 million US dollars.
And could you remind us of the capacities again?
Yeah, so Wigton 1 is 20.7 megawatts. Wigton 2 is 18 megawatts, and Wigton 3 is 24 megawatts. So we have a total capacity of 62.7 megawatts.
Good. That was it in terms of the questions. Right. But in terms of, since you're actually talking about roughness now, could you describe the Wigton site in terms of some of those factors? Like what's around there that makes it appear?
So if here at Wigton we are a little bit out of town, and the town in this case is Mandeville, which is the capital of Manchester. We are in what we call a farming district. So there are a lot of farms around us, but the farms are very low shrubs. So in other words, there are some carrots farming, agricultural, sweet potatoes nearby, but most of these crops, they don't have very high heights in their plantations in terms of their plant output or their leaf output. They're very, very low to ground. We do have trees around here, but they are not very high due to the strong wind regime that exists here. So many of the trees here are actually bent due to the flagging that we discussed. So the area, and if I could use back a slide, still think you're seeing the presentation slide. So we could use agricultural land with some houses and some 8-meter tall shelter. That would be more us here at Wigton. Also, we could use open agricultural area with fences and hedgerows with very scattered buildings, because there is a community nearby, and then it's a community of Rose Hill, but it is scattered houses. It is nothing that would interfere with the wind that is needed for the wind turbines. So that would be us here at Wigton. That is how I could describe Wigton here. I could look at, in my head, if I remember Bridgetown correctly, I could describe Bridgetown as, it's not very, I couldn't use a large city with very tall buildings. So I could use agricultural land with many houses and a couple of hedgerows with a distance of about 250. I'll wait for Barbados, Bridgetown. So it all depends on where you are. But just as a key point and a key take-home factor is the closer you are to zero, in this case, roughness length. So a roughness class or 2 or less, it would be better for your wind outputs.
Another question or two just came in. In the case of existing wind farm, for example, Wigton, with the rule of thumb specified, 1/3 height within 1 kilometer radius, is there any regulation prohibiting the future construction of buildings or the structures that might exceed that criteria and therefore affect your wind farm?
Well, let me see if I could think correctly. I'm not sure of the regulations, but I think that within the surrounding area of Wigton, it is prohibited for any large development of any very large buildings in front of our wind farm. In front. So there is a prohibition in place.
The local authority.
Yeah. So your
not in
local
place
authority.
after you guys
Right.
built. Okay, that is good to protect the investment. Couple questions more. Did you have any resistance from the farmers to establish the wind farms? And if so, how did you deal with it?
Well, one of the things that you have to do while developing, and we will discuss it later in the final slides of the presentation, is your community stakeholders. So your more immediate people that are surrounding you. So you will have your different meetings right through the entire process. So pre-construction, during construction, and post-construction. Because what you find is that, well, for us, Wigton here, most of the farmers welcome the development because it provided some temporary jobs. So within the construction phase, so many of the farmers are more the skilled laborers that were in the neighboring communities. They were hired here to work here, to whether it be bend steel, mixed mortar, whichever one. They welcome that investment because predominantly this area was known only for farming. Now, if you ask anyone what is it that you know about Wigton, they will tell you initially it's where the wind farm is, plus there is also some agricultural development that still takes place here. So your community stakeholders, you have to keep your town halls, your town meetings, you keep them regular, just to keep them aware of what is taking place. When is it that you will be doing some, maybe you will have to do some piling within the earth, whether it be some digging. When is it that you will expect a little bit more dust nuance, stuff like that. So, but it was done regularly, and still we continue to build relations with the community. So one of the things, and this is outside of this presentation, one of the things that we do here at Wigton, outside of our training lab for whether it be the surrounding area or the entire region or island, we have different water tanks that we had rehabilitated for the farmers. They existed on site for quite a number of years prior to the wind turbines. And one of the things that we did here was to develop the to develop the water tanks so that we could give access to the farmers to use that water whenever they want, whichever day they want. And we also take care of one of our primary school here. We have adopted it. It's the Rose Hill Primary. It's a little down the road from us, and we continue to develop that primary school just to bring them to the level of a primary school that would be one closer within the town. So being a primary school in the rural area versus one to the town, we have continued our development so that it could mimic an institution of one that is closer to the town in terms of its facilities and what it is there that they could offer to the students of the community.
That's good and worthy work. One more question before we move on. In your wind speed measurements from Anonymous, how do you assess the speed at hub heights? If the method uses extrapolation, how do you compensate for over or underestimations of the speeds? And the person adds, this question relates to the log and power laws. Studies have shown that they tend to lead to over or underestimations of wind speeds.
Right, so for us here at Wigton, we did both. So any meter that was installed was actually done at hub height. But we also use the lower anemometers just to give an idea and compare the two. So we compared the wind speed at hub height using the lower expectations. In some cases, you would have overestimation, and in some you'll have underestimation. But the fact that we had our wind speed measured at hub heights, meaning that factor isn't really addressed to us. Now, in some cases, you will find that overestimation, and if you have an overestimation, that can lead to a flaw within your investment. How is it that you account for it? Is two ways. You can use both methods. What I did in a study that I did back then in my thesis, I used both methods and then I averaged both so that I could compensate, because even though both methods are similar, they doesn't give the same output. So to account for any over or underestimation, what I did is use both methods and then average the final and then use that as the figure. So that's a next method that you could look at. Just as a means of compensating for any over or underestimation.
Okay, that makes sense. One more question.
Sure.
And then I think we do need to keep it pushing. What's the minimum setback requirement from downstream receptors for a turbine in Jamaica with regards to noise impact and or a tower collapsing?
So I could look at that further in the final slides because I have it here. It's a final discussion, but just as we mentioned before, for the noise impact, we have to analyze it. We normally, your manufacturers, they give the rating for the different classes of wind speed. So if your wind turbine will be operating at a wind speed, say it's a windy day like today where it's going to be a little bit more loud, you will have an idea of the measurement. Now, what you will do is before you will submit that data to NEPA, that's the environmental agency in Jamaica, and then they will see if it's acceptable for the surrounding community. So they will do their due diligence on their part and say if the community have an issue with the noise that you hear, and this is my personal opinion, if you were to ever visit a wind farm, it is, to me, I don't call it noise. It is a rather soothing sound, especially in the high wind period. But as I said, that's a personal preference. That's to me, not necessarily to someone else. So, but the environmental agency will do their community due diligence. They'll go around, they'll do their surveys to see if they can accept the tolerated levels. Because there is a tolerated level that is normally set by an environmental agency.
Okay.
I think he also asked of tower. For wind turbines, the tower structures are usually rigid. They won't fall unless there's an incident that can happen or some very, very strong earthquake that could display. But also your foundation is rated for a certain level on the Richter scale. I don't remember it out of my head for Wigton here, but it is rated. It has to be rated.
Okay, very good. I think we have about 45 minutes left, a bit less, so let's proceed, Sanjay.
Yeah, no problem. So this here is the final leg of the presentation. And now we're looking at quantifying wind data for wind farm developments. Just give me 1 second here. Sorry. So once you have identified a site, you will, as a developer, you will install a meter and you will do some remote sensing. You record your information. You'll do it for whatever time period that it is that you set. One of the key parts here, the key mention is to be considered attractive for project development. A site's annual wind speed should be around or should be more than 6.5 meters per second. And it should be strong at a wind turbine hub height. Here at Wigton, our average wind speed, I think, is around 8.2 meters per second. And that's for the year. So what you're looking for is an annual average wind speed of 7 and greater. 7 is good. For Wigton, we're within the region of excellent and outstanding. And there are many tools that you can use that could now give you the output or the idea or your average wind speed. Now, some of the tools that we have, sorry. Yeah, sorry. So some of the tools that we have is some of the software that is used. You can use for a quick snapshot or a quick analysis of data. You can use Microsoft Excel. It is powerful enough because you can create an hourly average graph, as you can see. You can create a wind speed distribution frequency graph. You can look at the average wind speed for the day or for the entire year. You have functions that can create wind roses, but what your analysis will use is more software geared towards wind farm design developments, and there are quite a number of them. We will list some of them later down, but this is just a snapshot of how one looks. And this one here is it's a tool from AWS, and the link is below, but it will be provided, where you can look at how is it that you can manipulate the data, what software is there to manipulate the data, so it can become visual. You also have 3D software, so computational fluid dynamic software that will be used to determine where on your site is it that you can install a wind turbine. Why is it that you should install it here versus a next location? You have software that can give you that kind of output. Now, this section of your assessment is normally done by different analysis that exists within or across the world or across the region. And you will provide them with this data, and then they will provide you with the different reports. They will take some time to crunch the numbers, and they will give you the reports. So the site assessors. So the other thing now you look at is access. But before you even, if after your assessment and after you got a report that says, yes, it is feasible for my wind energy development to take place, then you start looking at your road network or your road access. How is it that I could get my blades onto site? What roads do I have to widen? If I have to widen what path do I have to, what time of day do I have to drive? Who do I have to coordinate with to move around? So stuff like that you'd have to have an idea of. Also, you'd have to know the ownership of the lands. And that is something that you know beforehand. So even during the installation of your net tower, at that key point, you will start to look at who is it that owns the land that is here, the land that I want to develop, who are the owners, is it government owned, is it privately owned? You will have to understand or have to know that bit of information. You will now also have to know that where it's that you're going to get your cranes from, who will do where you get your cranes to install the turbines, where will they come from? Will they be from a local entity? Will they be from a regional entity? Do I have to hire from, do you have to hire from Europe or wherever? You have to start beginning to answer these questions. Connection to your grid. That is also something that you need to know from early. How far do I exist from my grid? So in the case of Wigton, Wigton being here, we are situated at least I think 10 to 15 kilometers from the connection point of our grid. So, and remember, always remember, the less distance am I to the connection point to the grid, the cheaper it is for me. Because 1 kilometer of high transmission lines, in terms of cost, it can run up to $1 million US for 1 kilometer. Meaning to develop that area to run the cables from a connecting point from your substation on site to your substation, to your connecting substation off the grid. It can run at least $1 million US. So the closer you are to the grid, the cheaper it is for you. So those questions you have to know. Of course, you also have to know what is it that the land that I'm going to be on used for. Is it just a barren land? Is it farming land? Who or what farmers own different parcels of the land? Stuff like that. So you always have to take into consideration those little details. And we can look at now the ground conditions. So once you are now there, you look at the soil stability, the site drainage, the site, when it does, if it rains, is the water collected here? If after me excavating certain sections of the land, will I disturb my neighboring community? You have to look at some of those analysis, and that's normally done with your land assessor or you call him a quantity surveyor. So you have to look at some of these things, where your wind farms exist. Do I interfere with air traffic, or do I interfere with broadcasting television signals, whether it be radio or TV? So some of the stuff that you also should look out for. If you remember, we had mentioned noise from the rotation of the blades, and also shadow flicker. How is it that those things are the visual impact of the turbine, because it is something that can be seen for quite some distance? How is it, or will it affect my community sites? So in other words, let's say there was a landowner who had a nice house with a nice view. With your turbine being built, will you impact her view? Will she have an issue with that? Some of the finer details that can come up. So most of these things are addressed during your community stakeholder meetings, and also your land, while you're doing your land surveying. So remember, they're talking about the rotation of the blades, what can happen? Well, noise can happen and shadowing effect can happen. So the aerodynamic noise, the rotation of the hub moving through the air, it will cause us, it will create a sound, like a whoosh sound. Does that noise, or does that sound, does it affect your neighboring community? If there is a neighboring community, will the rotation of the main shaft or the vibration of the generator throughout the tower, will that bother someone? Normally those vibrations are very small, so if you are in a neighboring community, you will not hear the vibration of the generator as such. You will only hear the aerodynamic noise created by the blades. But once you are analyzing for noise, you have to remember the threshold that is needed. So, and if you remember, I mentioned the threshold. The typical limit for wind turbines is 45 decibels a day and 35 decibels at night, and this is based on the IEC standard. And I think this is a standard that the local environmental agency use. So sound pressure decreases with distance to a source. So the further you are from a community, the less likely your community will hear any noise from the wind farm or from the wind turbine. But you realize from wind turbines, it is okay, you can talk over it, you can hear, but you just have to keep in mind any disturbances to your neighboring areas. So in a worst case scenario, when a wind turbine is at full operation at night, you have a decibel or sound level of 50 to 55 decibels. Will that sound impact your neighbors, or affect any neighboring community? Are they okay with that? Will they be not disturbed during their night stress when this is happening? These are some of the questions that you have to ask. Low conflict site. This is now a site where you have outcomes to avoid conflict rights from the beginning of the project planning, and you have a lot of advances where you already have access to different road networks or workloads for your different project planners. So your licensing authorities, now let's say your wind farm will be, hence most of these low conflict sites are offshore. It's very easy for them to say noise is not an issue because there is no neighboring community out in the sea. It's easy for them to say, okay, the public will accept it because it's not within their eyesight or eye line or the vision line, so it won't impact such like that. Now, if you were to exist in an area of a very busy town center, you realize you have a little bit more work for your project plan. So your different local agencies, and the agency will be listed in a slide further in the final part of the presentation, where your local agencies have a little bit more work to do. They will have to carry out a little bit more surveys to see if the community will accept the development, if the noise that is created during pre-construction, during construction, and post-construction, will it affect them? Will it do anything for the farms? Will it increase the tolerance for some of their livestock? Stuff like that. These are some of the stuff that you have to look for, whether it will be a low conflict area or a high conflict area. Now, if you remember, one of the questions that I asked, how far is it that you keep your turbines to reduce the wake effect? If you're looking at an in-front basis, normally you have 5, no, well, it depends. If it's a low conflict area, low, meaning you're in the sea, it is much, much further than when you're onshore. So if you're in the sea, it's 5 rotor diameters or 7 rotor diameters. And that is to reduce the wake effect because you have less interferences out there, so your wake effect will be a little bit stronger in those areas. So your area is needed, and they can show you and you can measure it, a little mathematics there, 5 rotor diameters or 7 rotor diameters. And I said these are low conflict areas. Now, if we were to use a medium-sized turbine with a rotor diameter of 70, what is it that now, how far away I would look at my measurement for? How far is it that I need to keep between both turbines so I can reduce noise? Because the closer your turbines are, the more disturbance you have from the wake effect, the more likely it is that the noise that is created the closer you are, the louder it gets. So the further they are from each other, the less it is for the wake effect, the less turbulence from in-front turbines, and the less, the less likely it is that the turbines are impacting each other. So now we're looking at some of the stakeholders who as a developer, you have to contact with pre and during and post-construction. So for Jamaica, you have to, and it's more or less the same throughout the different countries. So of course, your grid operator, your environmental agency, your utility regulator, your different ministries, your custom entities, and your ports, because that is where you are bringing your wind turbines through. So you're bringing it through either ports in Trinidad. It's listed as the Regulated Industries Commission, the Environmental Management Authorities, the Customs and Excise Division, the Port Authority of Trinidad and Tobago. Trinidad and Tobago, these are just the different agencies. Belize in St. Lucia, same thing. So once the agency is of a common factor, in this case, you see Belize Customs and Excise, National Environmental and Planning Agency within the Belize Port Authority. So in other words, it's your grid operator, your environmental agency, your utility regulator, and the relevant ministries that are there. Similar for Guyana. Now, once you have identified your stakeholders within the process, then you could ask these questions that are listed. What is it that my project will have an advantage to? Why is it my project is suited better than my competitor? What is so unique about my project that a next entity who is submitting a bid cannot compete with me again? Where do people, what do my community see as my strengths? These are just some of the questions that you can ask within your development phase. So what is it that I should avoid? What could I improve? Who is it within the market who is likely to see what am I doing here at my location as a weakness to the community or my neighboring area? What opportunity can be created? Can I take can I hire some persons from the area? What is taking place within the field of wind energy? Is the cost, are the costs getting cheaper? Is it getting more expensive? Questions like these you can ask within the entire process, and these are questions you have to ask whichever stakeholder. And then at the end of your stakeholders sessions, you ask then again yourselves, what is it that is the strength of my project? Where is it that I can see an opportunity, especially for my surrounding area or my neighboring community? And what is it that threatens my project? So if you remember during this entire presentation, the threats would of course be a hurricane that could threaten your project. An opportunity could be a development of a rural community. You could bring some structures. A weakness could be a community who says they have no interest in seeing a wind farm being developed here. And some of the strengths, and of course strengths of renewable energy, wind energy, whether it is wind, solar energy, whichever form, strengths meaning it lowers the cost of the electricity being generated within the different countries, especially the Caribbean, seeing that we are not necessarily known as net exporters of oil, with the exception of a few countries. We are more importers. So strengths, these are just some of the questions that you have to ask. Now, other threats, we can then look at climate change. What will happen or what can happen if there's an increase in temperature? As we all know, temperature is increasing steadily over the number of years. What will happen to the wind industry? So one of the analyses that were done previously is to say that with the variation in temperature, what can happen is an increase in wind. But the type of wind that is necessary for a wind turbine to generate is preferably constant. If that wind is too turbulent, then you can have a little bit more increase in the maintenance cost, because you will find that the turbine will be yawing a little bit more, your gears will be working much more. So an increase in temperature, which can lead to an increase in wind, can actually lead to an increase in the maintenance cost, because it's not necessarily the type of wind that you want associated for your wind turbine. Similarly, if you have an increase in hurricanes or tropical system, which also an increase in temperature lead to, that will then allow, so like a key example would be last year. Last year, 2020, we had a numerous amounts of, I think there was a record number of tropical systems, whether it be depressions or hurricanes. What is it that increase can do to my investment? Will now a bank look at me and look at the Caribbean region and say, all right, I would like to build a wind farm in, and this is just an example, in Antigua. And I think I have found nice land, I've done my assessments, but last year there were 10 hurricanes and a couple of them went close to the site. The year before there were around 5. This is just an example. Lending agency or financial institutions could look at this data and say, okay then, with an increase in hurricanes, this could actually be a little bit risky for my investment because I am lending you money at an interest rate for you to pay me back, and you are going to pay me back by selling electricity. Now, if there happens to be an increase in the frequency of hurricanes, and if there happens to be a direct impact of a hurricane, what will happen to my assessment or to my risk? Will I lose my value of money? Those are some of the questions that climate change impacts, or what can happen. Those are some of the questions that you have to ask, or some of the questions that you should look out for. An increase in rainfall. Now, let's say your lending agency is satisfied with your risk assessment of hurricanes and say, fine, I will still lend you some money to do some development. If you were to have an increase in rainfall, and this took place last year as well, and you're trying to construct, or you're in the construction phase of your wind farm, what is it that can happen? You keep having a numerous amount of delays, you will have to put off parts. These are some of the things that you can just look for. So, and I can speak here at Wigton Wind Farm experience. We had some large-scale projects that we wanted to undertake last year, but we couldn't because the weather was really, really unpredictable. It was very unsustainable. There were lots and lots of rainfall here. So those are some of the questions that you can ask. Another thing that you can also look at is considerations. So during the development and implementation phase of a wind farm, you can have family displacement. So remember that wind farms exist on large amounts of land. So here at Wigton, we are situated over 1,300 acres of land. If you were to displace a household or a residence, what can that do to that family? That family could be living there through generations, maybe for at least 20 years. This is just, as I said, example. So how do you compensate a family for that? So yes, normally compensation is done for relocation, but what psychological or social impact do you see or can arise as to a family that has to relocate? Some of the questions that you have to ask. And then job imbalances. So if you were to develop a wind farm and you have gender on your mind, as in you want to structure a good balance between the hiring of female and male counterparts, how is it that I can go about this? So within the country of Jamaica, and I'm not sure if it's the same for different Caribbean islands, most construction workers there are male, and that's just from history. So what you'll find is that there's not many female construction workers. So what you create is now you create a social distribution in terms of more common jobs that females normally operate. So you'll find women running bars or shops or temporary restaurants versus males doing the hard labor. And then the post-construction and the implementation of a wind farm, it doesn't necessarily lead to the hiring or the permanent hiring of non-technical people or skilled laborers from the surrounding areas on a permanent basis. So you can have a question like that being asked by you as a community member, say that, all right, you are coming to my community to build a wind farm. After I am finished bending steel, what guarantee do I have to stick around, to stay? You cannot provide such guarantees. So all in all, these are just some of the questions that you have to look out for in the entire phase or the entire construction phase of your wind farm. So whether it be from your initial viewpoint, once you visit your land that you want to develop, once you have an idea of the wind resource that is there, once you start beginning to quantify that resource, then which agency should I visit, should I contact, how do I move forward? How is it that I speak within my community to get my community on board? Because if you don't have a community on board, chances are you cannot get your development ongoing for your wind farm. So it has to work hand in hand, both. So on that premise, that will be the final part of this training session. And if we have any other final questions, we can ask.
Thanks again, Sanjay, for a good and jam-packed presentation. We have a few more questions. Firstly, and I guess this is touching on a question that was asked before, but maybe you can expound on it. Are there any considerations for offshore wind farms in the Caribbean that you're aware of?
It is something that is looked at, it is something that is considered, but the fact that we exist in the ITCZ, it is a little bit more challenging for us. So the wind over the Caribbean Sea, as stable as it is also very gusty, and we're exposed to that hurricane threshold during June and November, and that is at least 6 months out of the year where we're exposed to hurricanes. So that risk that is attributed to the ITCZ, we are exposed to it. So it is not something that we will say we're completely writing it off and say, no, we'll never give it consideration. But it is one of the more challenging aspects. The fact that we exist in the ITCZ, the hurricane belt, it's at least present for 6 months of the year. So there's a 50% chance that a hurricane will exist in the Caribbean Sea for those 6 months, just by being 6 months of a year. So it can be a little bit a detriment to any potential offshore developments.
If you had an offshore development, just like how you said, when you have this onshore farm and a hurricane comes, you have to go out and lock the blades and do this, that, and the other. You'd have to do the same thing for offshore, but it would be at sea, eh?
Yes, same thing. Have to. So you'll have to get, and maintenance offshore is done similar to onshore, but there is involve a lot more planning, and that's just by the nature of where they are located. So if you were to visit any onshore wind farm, chances are you'll find an office that will have just a little bit of an area where you can do a little bit of planning, but it's on site. So it's easy for you to congregate within the office space to delegate tasks and say what day, what time. It's rather easy because you're on site. When you're out by the sea, your office area is never, it won't be on sea. Of course, it will be on land. And so you'll have to take into consideration the weather patterns from windy or whichever weather tool that they will use, just to keep in mind that, and you'll have to do a lot more planning. So if you were planning a job and you go to a wind turbine that is offshore and you see a problem that you didn't expect, chances are you have to go down to or remove yourself from the turbine or phone in to say, okay, then I need a particular tool or a particular part, something that you weren't prepared for. So a little bit more planning has to go in place once you're offshore, or a lot more actually. You wouldn't necessarily have those issues on an onshore wind farm, where they will have a warehouse with the spare parts that will be on site. So you can remove little issues like that.
Actually, where are we at it? Even before you have an offshore development, how do you assess wind speeds offshore when you can't really erect a mast, or can you?
You can, but it will cost. But in the offshore space, that is where now LiDAR becomes key, because offshore investment, even though it's much larger than an onshore development, they have the ability to generate more revenue just by nature of their existence in a low conflict area. So they can account for that capital investment of a LiDAR system. So they can afford that within their investment scope, within their capital cost.
Okay, that makes sense. Another question now, more around operations. How does a wind turbine react to grid load changes? Similar to hydro or solar, or is it more rapid?
Because of the type turbines here that we're coming from, they are asynchronous. Any grid imbalances doesn't really affect us. So what we feed to the grid is what we take from the grid. If you understand. So we're always in sync with the grid.
Got you.
As the nature of our generators here within the turbines, it's asynchronous.
Okay. I think we have another question coming in. Just a moment. Actually, a comment.
Sure.
Very excellent and informative presentation by Mr. Sanjay Simon. So big up yourself, sir.
Much thanks.
I have a question now, Sanjay. Since you and Wigton too really have a lot of experience in wind resource assessments and so on and so forth, do you guys offer services to countries or developers who might be interested in doing a wind resource assessment? And if so, how could they engage you?
So it's that would be more a question for like the management team, but I can answer. I have an idea of how to answer. We're always willing to help and assist. So if you are within the region and you have some project in mind where you want to undertake some wind development, all you have to do is reach out to us and then just create a contact, and then we will keep in touch, and then we go from there. So it's not necessarily like a part or a direct part of the company where that say we offer such and such service at such and such cost, but it's more if you have a project in mind, you can reach out to us, and then from there we continue dialogue and to see how best we can provide such assistance.
I'm glad to hear that, because again, quite a lot of expertise at Wigton, and you know, it'd be good to use it in the region more and more. I should mention to the audience that Wigton Wind Farm is one of CCREEE, that is the Caribbean Center for Renewable Energy and Energy Efficiency. They are one of our thematic hubs. Basically, we have a network of institutions throughout the region that have particular expertise and certain skills. So if somebody were to come to CCREEE, perhaps to access assistance through our project preparation facility, and they had a wind project and they needed some specialized wind care or wind expertise, we might activate Wigton, come to an arrangement, and therefore get that expertise used on the project. That is at least ideally how it would work. We're just waiting for people to come to us and ask. I see another question coming in. What has been Wigton's experience with annual maintenance costs for wind farms? How would they rate the annual availability and reliability of the turbines?
All right, so on a phase-by-phase basis, we have operated within the recommendation from the manufacturers. So we have operated within 90% availability for the 3 phases for quite some time. That is our standard here. That is what we look. Of course, there will be months that you won't maintain 90% because there will be months where you'll have turbines that require large-scale maintenance. But for the most part, on average, for phase 1, we have an availability where we try to keep it above 90%. For phase 2 and 3, it's 95 and 98%. Phase 3 being the newest one. Of course, as time goes by, the older the phase, we reduce the availability a bit by bit. So hence, phase 1 is 90%, phase 2 is at 95, and of course, the newer one, phase 3, that's 98%. Costs in the initial stages, it will not compare to your revenue. Your maintenance costs are low. But as time goes by, if you think about it like a car, the older the car gets, the more it requires a little bit more service and requires a little change of the parts here and there. It's the same concept behind a wind turbine. The older the turbine gets, the more you have to do a little bit more maintenance. So your maintenance costs increase as the time of the turbine goes on or increases. It will
Actually,
not. Repeat?
sorry, on that very note, is there like a time at which you might
Like an
retire a
expiration
wind
date?
farm?
Right.
Yeah.
Yeah, so I was leading to that. So your turbines are normally rated for the life of your PPA. So that's a power purchasing agreement. That's a contract that you and the grid provider will have, where you sell them electricity for a certain time period, whatever that time period is set by PPA. For us here, it depends on phase. Each phase have their own PPA. So the lifespan of the turbine will increase and it will go up to 20 years. So that's normally the lifespan of a wind turbine, 20 to 25 years. And your PPA will last for that time period. Now, whatever the electrical entity or utility entity is, this is now a discussion between the utility regulator and your grid provider in this case, where you determine the length of your PPA and the rate at which you will sell to them at. After which, once you reach the end of your PPA, some entities they will allow for a 5-year continuation, and then within Europe, I think in some countries within Europe, you are allowed to repo one in the States. So once you reach the end of your 20-year PPA, they allow you to remove or repower your turbines, whether that be replacing nacelles or you replace the entire structure within the same area, and you continue generating again for the next 20 years using maybe newer technology or newer turbines under a new PPA power purchasing agreement. So it all depends on country and legislation.
Very good. I have another question coming in again from our resident generation expansion engineer. Great presentation, Sanjay. Read labor. Could you speak more concretely about labor requirements during construction and on an operational farm? For example, how many jobs created, contracted, or outsourced versus permanent, imported versus local? Them kind of questions there.
Yeah, man. So one of the good things here that is done here at Wigton, and this is post-construction, is that all engineers here are local. So after, and now let me look at, so wind farms within the global hemisphere, you have two ways how it's normally done. It is sometimes done by and this is not the maintenance, that's normally, sometimes it's done by the manufacturer, where they will lock in service contracts of maybe a 5 or 10-year period. And it is better for them as the manufacturer because they get to keep generating revenue by providing servicing. Now, there are some wind farms that are operated as owners, and they're owners and operators of their own farms. So here at Wigton, that is the case. We are owned by at least 13,000 shareholders, as mentioned earlier, but we're operated here by the staff, and the staff is entirely local. Now, at the initial stages of the commissioning of the wind farm, you will have a service period normally provided by the manufacturer of 2 years. So what will happen in that 2 years, a transfer of knowledge. So the manufacturer will be servicing the turbines while you will have local engineers undertaking or just learning as much as they can for those 2 years, until after which the local engineers take over the process. You know, that has been the process that has been used here at Wigton. We have around 8 or 9 engineers, and we have 8 technicians here that work in sync together with each other to maintain or run the wind turbines. Now, what does that do is to allow, and that allows a transfer of knowledge to stay within the country. In other words, you don't allow for a brain drain. So engineers or renewable engineers, in fact, wouldn't necessarily have to leave the Caribbean to exit and go seek better opportunities, which was what was the case here at Wigton, by hiring local, the knowledge and the power stays here. So that is what is normally done at Wigton. Of course, in the pre-construction phase, you will need different levels of skilled laborers. So what sometimes is normally done, and after announcement is made, within your community meeting, your first meeting, you will say that you will need X amount of jobs. And I think the number of jobs that was created in the different phases was around 100 to 200 for each individual phase. So that, of course, involve different diggers, excavators, steel benders, mortars or masons, all of those that are involved during the construction phase. Now, after which, as I said, those are more temporary type of jobs. Then the only thing that we outsource is when we have very large scale jobs. So in the initial stages as well, when we have undertook large scale jobs here at Wigton, we bring in a little expertise from overseas, and then we allow for a transfer of knowledge within that 2-week period, however long that project was. So since 2016, for phase 1, all the repairs for the nacelles for phase 1, or whether it be the large scale components, have been done by us engineers. We have not brought in any outside expertise leading up to starting from that year. Prior, we brought them in just to gain the knowledge or increase the wealth of knowledge that was needed to do it, and then after which we move forward. We just did it ourselves. And that resulted in cost savings. Because normally when you undertake these projects, as in when you bring in foreign expertise, it can lead to a very increased cost.
Good point and a good place on which to end. Comment on our close because we only have about 2 minutes left. So I want to say thank you, first of all, Sanjay, for a very informative presentation. I thought I knew a bit about wind. I learned quite a bit from this. And judging from the number of questions that we had, clearly there was a lot of learning going on. So very worthwhile. I hope that people keep Wigton in mind as a center of excellence, as a center of knowledge and resources in terms of deploying wind energy from the Caribbean. They are one of our own, they are a CARICOM entity, they are one of our hubs, and so we think there's a lot to offer there in terms
not
of...
to cut it, Gerald, we also have an upcoming course. Just remember that we have a training lab here on site, and we have our upcoming photovoltaics course, which is assured by the City and Guilds Group. Yes, we're still in a pandemic, sadly, so we will maintain all protocols as issued by the government during this course, and it is April 2021. The actual date, it's a tentative date, and the date, let me just give you before you go, is the 19th to the 23rd. So
in person only, or does Wigton offer webinars as well?
No, for the nature of the certification, because it's from the City and Guilds, for now, yeah. So we need practicals, and it's, I have a couple assessments. So for now, it's in person, but we're working with the City and Guilds to see if we can bring a portion online. We just have not reached that level as yet. But yeah, we're just pointing out that we have our training courses running this year again. And also, my final statement would be to thank CCREEE for the time that was issued to us here today at Wigton to just bring about or increase the knowledge of the different participants here today of assessments from different islands. We ask you from Wigton to continue to stay safe. The pandemic is still ongoing, it hasn't stopped. So continue following the different government protocols and just keep yourself and your family safe. So from us here at Wigton, we thank you, and we thank CCREEE, we thank the different sponsors, we thank Gerald and the different organizers of today. It was a well executed event.
Thank you, Sanjay. It went very smoothly. Want to big up some of the other people behind the scenes. Big up our IT assistant / manager, Galen here. Big up Penny Bowen, who's been in the Q&A and who has been managing our communications and PR. Once again, I'm Gerald Lindo. We are CCREEE. That's 2 C's, 1 R, 3 E's. Go to ccreee.org. to find out how CARICOM and its organs are working for you to advance renewable energy in the Caribbean and continue to improve Caribbean lives. Thank you for attending this event. We will have many more. Visit the website to see what's up next. We have events on the 23rd and the 2nd of March in this IRP series. Thank you for your attention. Have a good day.